Hello. So please raise your hands, and not now. Anyone who knows, you know the question. Who know what means substitution?
No.
Okay, it's just my curiosity. And I don't remember what is a presentation about, so yeah. So this is a definition in Cambridge Dictionary, if I remember well. The use of one person or thing instead of another. So in other words, we can say that this is replacement. But in same time, it is something more. We can use word substitution in common speech or talk, but it is widely used in different places, like neuroscientists. So in neuroscientists, there is something called sensory substitution, and it is about replacement one human sense with another. And one of the most common example is Braille alphabet, which means that the tactile senses are substitutes the sign senses. So this is the reason why blind people can read. And there is another example with another substitution. This is Eagleman West. David Eagleman is a neuroscientist, and he created with his team a West, which include multiple matrix with vibration motors. And based on those vibrations, he created different patterns. And after teaching and training people, the person could start understanding what West trying to say to him. And for instance, they did an experiment when a person who lost his hearing ability trained with this West for 2 weeks, and he started to recognize words which another person talked to him. So in general, there is a TED talk on YouTube with Eagleman. It's very interesting, so highly recommend to watch it if it sounds interesting. But why it is interesting for us? So sensory substitution. In this example with tactile and sign senses, where finger and or eyes could provide information for our brain, it is, we can say that for brain it doesn't matter was text read through eyes or through fingers. The only thing which is important, the data that our brain receives. And please keep it in mind. We will come back and we will need this analogy later. The Doctrine of Useful Objects. Hello, I'm Alexander Repnikov, and I'd like to introduce you concept of useful object, but I will concentrate more on practice part of this concept, because in internet there is quite a lot different materials related to useful objects, but in my opinion they lack some examples, and I will try to cover those missing parts. So if we talk about useful object doctrine, we should talk also about event-type project. Event-type project is event sourcing toolkit created by event-type company. If you was on this year on the Wroclaw, you probably hear the speech of Scott Belver, who is co-founder of the event-type project and also the author of the doctrine. And this is the main connection between event-type and doctrine, which we will talk today. Also, this project is not only about event sourcing. The big part of culture of this company is about sharing knowledge and philosophy of programming. Scott is extraordinarily experienced engineer, and his level of understanding different patterns and paradigms of the programming is on completely different level than common person. Each time when you listen him, he describes things in unexpected way, which can open you some new secrets of things that you think that you already know. Also, Eventide project has amazing community on Slack. If you have any questions about Toolkit or about any programming pattern, you can ask there, and for sure you will get support from the team, and not only from team, from community, because there is a lot of very experienced person. And I forget to turn on my dictaphone because I want to record myself. So let me do this for one moment. Okay, sorry for that. And the doctrine itself, I think it's enough of advertising why we're talking about this. In general, this doctrine was created by the person who I think is experienced enough that we can believe him. And if you miss the conference on Wrocław this year, this is QR code where you can watch this. Highly recommend. He talked about the same thing, but more about theory and philosophy, and I will talk more about practice. So, what is doctrine about? And it's more how I understand or how I imagine the doctrine was created. So, in general, if you take some multiple patterns and apply it to your code, in result you will receive or get well-maintainable code or class. Then you will try to describe this class with some criteria, and afterwards you will use these criteria to create another class. And in result, the new class will be compliant with all patterns you used previously. This is the main idea behind this doctrine, at least how I see it. So let's read the doctrine, and of course it's not a whole document, it's just an introduction to the doctrine. An object must be useful immediately upon initialization of the object. No dependency of the object should ever be allowed to be uninitialized. If any use of any of the object dependencies result in nil reference exception, then object is not useful. So it's quite abstract thing. It sounds good, but just by reading this doctrine, this sentence, you probably not understand why it is good, why you should do this. It's just convenient thing, but to achieve those goals, there are a whole list of other criteria. So, as I mentioned, I'm not here for theory and philosophy, but we need to go through these points briefly. So let's start it. Of course, usable object should be usable immediately, obvious, as we just read. Next, it should be behavioral. Well, it takes its source from object-oriented programming. Objects or classes should be behavioral, so it is slightly different from what we have in Railsway. In Railsway, we mostly create not scripts, but how it was the word. I will recall this later. Okay, next, single purpose. Obvious, we all heard about single responsibility. Single purpose is very similar, but slightly different. We can talk about this with some beers later, if you are curious. Next point is that in an initializer shouldn't be any logic. So it should only assign parameters. So, in other words, there shouldn't be case when we create other objects inside our initializers. Our goal is to have initializer which always will be successful. There shouldn't be case when our constructor or initializer arise an error. We always should receive the object when we trying to create it. Okay, next. Difference. We should formalize the difference between initializer arguments and setters. And this is more about we often prone to put more arguments to our initializer because we will need those things like some dependencies, instances, but things which should go into initializer should characterize this object. So for instance, we have table, and this table, what is his characterized? For instance, number of legs. So we can say 3 or 4, maybe more. But what could be? I think you see my point. I don't have another good example what shouldn't be related to table, but good example in general is are dependencies. We shouldn't put dependencies in our initializer. We should set them with setters. Okay. Also, we should avoid foreign mechanism outside our class. So idea is that the class itself should be responsible and able to create an instance. So that shouldn't be case when there is some type of our instances of our class, which our class is not capable to do by itself. I will show you later in code the example because it could be confusing right now. And the last 4 points is about testing. So we shouldn't pass nil or dummy values to initializer just to prepare our test. We shouldn't disengage dependencies, which means not using stubs, dubs. We should have some telemetry and options to observe what execution of our objects, and we shouldn't use for that any doubles, mocks, because they are brute force techniques, and we will talk more about this when we will see some code. Okay, of course everyone already memorized all the points, and I understand that you already know everything about what I just said, so we can continue our presentation. But just in case if you miss something, this QR code is to this doctrine, and of course this document is long. It's like a proof of concept, or maybe in general it thing that we just said or read is just about what it is, but in this document you will see examples and explanation for each point, so it's very useful to read if you want to use useful objects. Okay, and as I promised, let's go to the code. Let's start from some extremely simple example, and I call this as a hard-coded version. So hard-coded, I mean that our dependency creation is hard-coded. So we have 3 players, and for simplicity, we can say that we have caller, service, and dependency. You can think about this in this way, but to make it more close to our production cases or our applications, we have a controller which plays a role of caller. We have create purchase, which is service which we use, or operation if you are familiar with Trailblazer, which we use in our controller, and create purchase is dependent on our another service which is send mail. And I'm not sure, do you see the comment? This service sends emails. It is not delay job, and I did this in purpose. So in general, we should be careful with this, especially in tests. Okay, so what issues we have here? First of all, send mail. Do I have? Oh, I have Laser. So send mail is hard-coded to our service, so there is no other option to test it, but only to mock it in test. So the problem with mock is that the life cycle of our mock is independent from life cycle of our implementation. What I mean, when you implement a new solution, or let's say you update your service, of course you will update your mocks and tests because we are good developers, but there are cases when we miss something because each mock is placed in separate file. It's spread through all your application, and there could be a case that you have 10 files where you have different mocks for the same thing. You update the service, you update only 9 of those mocks, and you missed about 1 of them. And it is possible that when you run your tests, the test is green. But it's obvious that one of the dependencies are stale. They are not compatible with our new version of service. So it will cause runtime error on the production and some other problems. And I saw such case at least 3 times in my career when someone just missed some mock. The more obvious case or more frequent place where it could happen when we update a gem. Gem is completely separate thing from our project, and we often want to mock it or disengage from our solution in tests for different reasons. For instance, let's say that this gem is making some requests to the internet, so we want to avoid that. And in these cases, when gem is updated, we update the gem. We probably not read what was changed and just run the test and expecting that, oh, everything is work because we have green test. But afterwards, we have runtime tests, so runtime errors on production, just because it is how it happened with mocks. So I never was a fan of this strategy. So let's change it and use one of the most popular solutions for that, which is dependency injection. So we have our hard-coded, on the left side, we have previous version of code. On the right side, we have new version, so it's like a transaction. And this arrow just tries to show you what we changed. So we move this dependency, this code, to our caller, to our controller. And additionally, in our new version of service, we add a new argument to initializer. And just because I'm not sure, it could be confusing, we are going through next steps from very bad solution to better solution, and in the end we will come to the useful object. So all the examples I am showing you right now is evolution of our solution. So since we started from hard-coded version, now we're using a dependency injection. We have our argument for a setter. So for our initializer, we assigned to the instance the dependency, and this is in general how is implemented. One of the options how you can implement dependency injection. So let's analyze what issues this solution have. First of all, why should caller know anything about our dependencies? Right now, controller is responsible to prepare all our dependencies before it even create us. So it's at least inconvenient, and you can imagine that we have, let's say, 5 or 7 dependencies, then we have 7 objects which could be not obvious that they should be related to our service. So this is the first thing. Another, it requires additional argument in our initializer. As we said, I hope I have slides for that. So we have it is not incompliant with 0.5 and 0.6 from criteria for useful objects. Let's see. The 5 was difference between initializer, arguments, and setter. As I mentioned, we should pass to initializers only those values which characterize him. And this example, it shouldn't be like that, okay. And this example I did in purpose like that. We want to create a purchase, but at the same time we are dependent on sending mail. So from object-oriented perspective, purchase is not characterized by sending email. It's a side effect, so it shouldn't be his argument in initializer. It is not a characterized part. It should be set as setter. And we will see this later. So the point 6 is about foreign mechanism. And again, our controller is preparing data for us. So this is outside mechanism, which is required to create our instance. And it is not compliant with useful object doctrine. Okay, so it has more issues. It requires a lot of setup in unit tests. And it's obvious, because if you want in unit test create this instance for your test, you obviously need to prepare all dependencies the same as we have in controller. And again, if we have a lot of dependencies, we have a lot of work to just set up and prepare our test, which could not be readable later. It's common to have file test which has, let's say, 50 lines, maybe 80 lines, where the testing part only consumes 15 lines and the rest is just setup. So if you open such file and trying to quickly understand what's going on, it's extremely hard, especially if you're new in the project. So in general, it's not convenient. Yes, I understand. Convenience may be not a good argument. I want to work in convenient environments, so I hope you too. So, but bear with me. I will show you later what could be convenient. Please bear with me. Okay, it's supposed to be my pause. Okay, is it clear for now? Any confusion? Should I elaborate somewhere? Is it okay? Any questions? No? Great. What a beautiful public. Huh?
All clear.
All clear. Phenomenal. Okay, so let's solve some of the issues and let's change our dependency injection. So instead of passing it to the initializer, let's use setters. In this case, we still have our preparation of our dependency instance in color. What I changed here? Yeah, so again, left side, old code, new code. So as you see, this previously we put our dependency as a argument to initializer. This time we create just an instance and then set the dependency. So this is the main difference. In service itself, it changes because we can replace our initializer and just use the default one without any arguments. And we have instead author accessor to have ability to have reader and setter.
I've got a question.
Mm-hmm.
The very first point of this useful object is usable immediately upon initialization, and this is not. And you will get to it later.
Issues. But yeah, thank you for being careful. Okay, so colors still know about dependencies, so this is still the problem. We solved the problem with initializers, so right now we are compliant with 0.5, which is here. Yeah, we clearly know what is argument for initializer, what is setter, but we still are not compliant about outside mechanism, so it's still here, unfortunately. And we made it even worse because now it's not compliant with 0.1, which is exactly what Czarek said. It should be usable immediately. If you look in the code, if we create an instance of this create purchase just with the initializer and not use setter for our dependency, it will rise no method error. So yes, this is not acceptable, at least for our concept. Let's change something. It will not solve all problems, but we'll be closer and solve some of the issues we already have. So let's introduce build class method Again, left side old, right side new. So in old code, we had our dependencies preparation here. Now we move this to a build method. So what our build method do? It creates an instance and then use setter for creating an instance of our dependency and return the instance itself. So in result, in our new solution, we have our controller, our caller, the actor who plays role of call. It can just create a purchase with our build method and call it without any additional setup. And what we gain with this option? First of all, caller doesn't know anything about our dependencies, and this is great. It is very convenient. Class is able to create fully functional instance by itself, so we don't have outside mechanisms which are required to create an operational instance. We can do this by ourselves, and if you think about this, it should be like that. This is the class who creates objects, so class should be able to create fully functional things. We shouldn't look in our code how to do that. Okay, but there's still remaining issue, and it's exactly point 1 about no method error. So we still, if just initialize an instance and call it, it will rise and no method error. So how to solve this? And why? So it's not incompliant with P1, and we need some default value for our dependency. This will for sure solve the problem with no method error. And if we put our dependency instance here, okay, it will solve the problem of no method error, but this is the same solution that we have in the very beginning. It's still hard-coded. So we come back to the point where we started, so it's not a good option. So the same issues that we had previously. So what we should put here? We need to find something, because in general, if we find this thing, we will have a useful object. So idea of assigning some default value is interesting. Also, it will solve the no method error. And but what is this instance? Sounds interesting. So let's come back to the concept or topic we started at the very beginning about sensory substitution example. And let's think again about our brain and what is important for them. So brain, it doesn't matter what text read through eyes or fingers. Let's code this. So we have our brain. No, hold on, no. We have our brain, hopefully. And so the brain wants to have the action dependency read text. And of course, it will call this action afterwards. We have our service which implements the reading of the code, and it's supposed to have some dependency data source. And so we have the same solution as we have previously when we had the build learning class. And for brain, it is not important, was it eyes source or was it finger source here? In both cases, it will read the stream. So when two classes are the same for from caller points of view, same names of all public methods. So if we have two classes and they have the same methods, then it's okay. The same names of class. So in general, I'm trying to explain an interface. Yeah. So we have the same methods with same methods with same names. Sorry, we have each pair of method has the same set of arguments. It is also important. And what is important that methods return the same type of result, but it is not required to return same value. They could return something else. It's up to us. In this case, we can call those classes substitutable. They are a substitute of each other. Class A, and hold on, I again missed the button. Class A could substitute class B, and class B could substitute class A. And I use word substitute in purpose. I want from you to remember this word because it's important. But in general, it's what idea is that we can replace class A with class B without any problems. Everything will work. So this is the core idea. We can go further with our theory or strategic. In general, we can generalize this rule. The class is a substitute of another class if this class includes all public methods of the other class. What it means? It means that the class B could have his own methods, but still could be a substitute for class A. So class B in this case could be a substitute of class A because he has all those methods, arguments. This part of interface is the same. But because he has his own methods, in this case, class A couldn't be a substitute for class B. And this is quite a useful feature of the substitute class. So let's look at a more production-like example. In general, it is almost the same that we have, but with more code, more dependencies. What do we have? We have some class create purchase. It's a service, of course. It is probably called in controller. It has dependency to purchase policy. And now I will describe you again the hard-coded version, and then we will apply changes that we already know how to do. So we have purchase policy, which if our user is not permitted to create a purchase, it returns false. The same with the form. We have some purchase form which validates our data. We need some attributes, and we also need prepare some third-party magic. It's our gem which we use and use magic. And we have transaction because we all need transactions in our life. So let's look into this. Of course, and we have some errors from which will help us to roll back the transaction. Let's look on the transaction, what's going on inside, because we will work mostly with this part afterwards. So we have some persist purchase service, and I did this in purpose. In general, this is the service which just creates an instance of our model and save it with this sign. How? Bang? Oh, okay. 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 Thank you. And we called our third-party service, and then checked was it successful. If not, we raise the error which we just defined. And in general, idea is that if after we creating and saving our record or our model in database, something goes wrong with external service, we should roll back our changes in database. This is the idea behind this code. So, oh yeah, I forgot that I have prepared slides for that. So once again, beautiful. Now what? So this is the whole solution. This is the version, hard-coded version, because we have our dependency hard-coded into the method. So let's again translate it to build method. So let's create our instances for our dependencies in build class method. This is the part. This simplifies a lot our call method. And since we have limited amount of space on our screen, let's remove most of the dependency and keep just some of them. In general, we have all the dependency, but I will show you only one of them, the most complicated case, because it is inside transaction and most interesting. Also, I replaced this service with simple active record. Again, just to make it smaller code. And what is important here more? Now we have the place for our code, which creates a substitute. So in general, our dependency, third-party magic, and this, please do not watch. I see, I made a mistake. There should be instance. And so, yeah. But idea is still the same. Here we create our dependency instance and assign to an instance. And here we have our default case, for case when we just use, instead of use build method, we use initializer. Then we create we use default value, which is a substitute in this case. And what is important here, all substitutes, and this is the part of the rules of using substitutes, they are a sub namespace of the class that they substitute. So as long as our service from our gem is inside useMagic, then we have a sub namespace substitute here. Okay, so great. Just because we have this default value, which is a substitute, so it works as we talked about fingers and eyes. They could replace each other. So we have user object. It's great, but how to create substitute? Let's create first. First substitute. To be a substitute, we already set all the rules that are required. So all methods, they should have all methods, public methods, as useMagic class. So there was only call, nothing else. It should have same arguments. Call doesn't have arguments, so again, good. It should return the same result, and we have response, which have some result also. But okay, first of all, let's be happy because we have a substitute, finally. But what is important to mention, I assume that the response class is somewhere in our project implemented. I will not put it in my slides. So the previous substitute was at least not usable. It has no usefulness for us. So let's make it more useful. And let's create some additional methods. And as we said, substitute could have his own methods. Now, because we have a method, it succeed, it creates, it sets, and probably I should say how it works. So in general, idea is that when we have instance of our useMagic substitute and we call, it return response, and response has default value. Very simple. So if we want to change the behavior, we have two methods. If we want to receive successful response, then we could call it succeed, which assign to the instance variable inside substitute the value, which afterwards will be returned with call. And the same is for it will fail. So we have now ability to decide would be the next call successful or not. But it doesn't have any telemetry. We can't say what exactly our instance received, what arguments, what methods were called on there. So we need that. So let's do this. And as I said, response is somewhere in our project. So right now I changed slightly layout. Now it is not old and new, it's all new. So just treat this like a beginning of the file and the end of the file. I did my best to remove all unnecessary code, but still it's small screen. So we still have our call method, but we want some telemetry. We want to know, was our substitute called ever? So if our instance received the call method, then it saved was called and set to true. And then we have an additional method with question mark, which can say, was it called or not? We still have our response part, which we have previously. This is the part which is our telemetry. So we have internal logic which can provide now us additional information about what happened with the instance. Okay, let's look, because previously it was a substitute for our gem. Again, not those buttons. Excuse me. So it was for our gem. But as I mentioned, in our service, we have also another dependencies like policy, purchase policy. Let's create another substitute because it has slightly different requirements. So from point of view of this purchase, it doesn't have method call. It has create purchase. And it could have multiple actions or multiple methods that could be called on that. And we want to have information what exactly which methods was exactly called on this instance with what arguments. And we can do this in this way. When our substitute received the create purchase with argument user ID, it has internal memory. We can think about that. It's an instance variable, which just is a list of all saved method names which the substitute received, and also the argument that is received. And just because of that, we can then check what argument was called previously with helper method inside. I will have test examples so it will be more understandable what's going on here. So I don't remember what I wanted to say here, so let's see what we have next, please. Okay. Okay. So right now, after we have multiple substitutes and we know how to create them, hopefully, now we what changed in our service? First of all, we have build method, class method, which is our constructor, and the purpose of this build method is to create operational instance which is supposed to be used on production. It is real. It's like if you have dependency which will send email, you will get this dependency here in build command. But our why you stop working? But initializer creates operation instance, so we still can call them, but they are safe. They use substitutes instead of real dependencies. So, for instance, they will not send any emails, at least if we not program them in this way. And also, they intended to be used in test. So what happened? We changed default behavior of our class. If you think about regular services that we create all the time, when you create an instance of the class, you think about how this instance is supposed to work on production, how it's supposed to do stuff it was created for. And afterwards we think, okay, we need to test, so let's use mocks and disengage all our dependencies. Because we don't want to mess, we don't want to charge our credit cards, we don't want to send emails or etc. But in this case, by default, we create an instance which is safe. It is the purpose of default instance is to be used as testable instance. It is not. It's never will be a purpose to use on production. And what is even better, you can use this instance on production server and experiment with something, and you can even initialize some of your dependencies. So you have ability to control what part of your service will work for real and which part will be substitutable. or substitutes. Okay, let's write some tests, and I have only 10 slides, so okay, so successful scenario. In this case, of course, we create our service instance. We have and since we use new, all dependencies are substitutes. So if I call policy, it is a substitute instance, and it has built-in methods, which I forgot to mention earlier. Sorry for that. Also, so we have it. It should be somewhere here. I'm missing part. This method should be supposed to be updated. Yeah, sorry. I finished this presentation today. So, in general, policy has a method, the substitute policy, create purchase permitted, which means that we configure our policy to permit any actions on that. Also, we have another substitute which builds validation forms, and we said that the next one will be valid. So it will create a form which will say that all data are valid. And of course, we have third-party magic, and we configure it that it's supposed to be successful next time. So we have successful scenario. We prepare some additional data which are required. Of course, we need user ID, and of course, we need some parameters because they are argument of call method in our create purchase. And we call our service and expect that it will return true. Also, we can use our telemetry and check that policy was called with inside was used method create purchase, and also it received the arguments. And so we can we have this ability to check what exactly happened inside our service. Also, we can check that our third-party magic was called. So again, we have ability to check what exactly happened. As we saw, we already created that this is the default behavior. Our policy are built right now that they are successful. So in theory, we could remove this part and do our test even smaller. But it's not always a good idea, because sometimes it introduces the issue which is called mystery guest. In short, when that test reader is not able to see what was the purpose, or what was better to read. The case the test reader is not able to see the cause and effect between fixture and verification logic, because part of it is done outside of the test method. So if we have something like in factory bot, you put some additional information and you don't have it in the file of your test, then this is the mystery. You don't know what happened inside factory bot. This is what, in short, what it's all about. And another QR code for those who are curious. But mystery guess is quite interesting issue and quite common. So let's do another test, and this time we want to have failure case. So our third-party magic fails in this time. So again, instance, and this time we as I mentioned, we can skip those dependencies because by default they are successful. So we need to only set the one which is supposed to behave not according default behavior. So we will say that third-party magic will fall next time. Again, attributes, we call our purchase, and this time we expect to receive false from our service. And again, we can check what exactly happened inside, and this time is again the same. So we have difference here, but all those methods were called. So our service inside worked as supposed to. More tests. So this time, let's say that the action is unpermitted. So in other words, our user is not permitted to create a purchase. In this case, we use only policy dependency, and we're saying that create purchase is false this time. And we don't need to create any other dependencies because they will not even called. So we can keep the default behavior. We can now we prepare our attributes again, call, and again we're expecting that service will refuse, so it return false. And also we are expecting that our policy was called with expecting arguments. Yeah, it's here, but this time our two other dependencies, form builder and third party, is not called, and it's correct because we in our code we have return false if policy is not permitted. So let's some benefits, introduce those strategies and techniques. First of all, substitutes lives with implementation. As I mentioned about mock is the place where you put mock is inside test file. So, and it is highly possible that you can miss some of the mocks because there are multiple places where it is. Of course, you can create some shared tests, and it will help to maintain your tests. But substitutes, as I mentioned, live inside the namespace of your implementation, and it is your responsibility as a developer to maintain not only your implementation but also his substitutes. So why it's good, since we have centralized code base, which means we have central place where code of substitute lives, and we are responsible each time to update this place. You can even imagine this scenario. Let's say that you have a service, you update the implementation, and you for sure will update at least one test. It's for sure because you need at least one test. And when you implement your one test, you see that your substitute is not anymore compatible with implementation. So you are forced to update your substitute. In result, you have implementation, substitute, and one test updated. But if you was not aware that somewhere in your project there are other places where you use this same substitute, then now when you run all tests, those other places, let's say you have another 3 places where your substitute was used. Now these tests are not compatible with your substitute. So there is no cases when you miss something and you have green tests and runtime error on production, because of this connection between between life cycle of your substitute testing tool and the code itself. Okay. By default, we create safe instances, so we can create partial dependency. I already said about that. So in general, you can play safely with your instance. Nothing will break or explode. What else? Also, by design, you provide a tool for testing. And yes, you might think that, oh, I create a gem and I not only need to test my gem, but I also need to provide a testing tool for my gem and test this testing tool. It's twice the amount of code. But afterwards, especially when you work in a team, if you provide a test tool for your teammates, it will speed up their work. First of all, you suggest how to use your code with substitutes. Second, you suggest how to test your gem properly. And third, it is not has less coupling between one application and the gem, because you not put mocks or things that trying to simulate logic from your gem inside other parts, inside other applications. Everything is inside gem, and you just use those other things. And I mean substitutes. Okay. And what is great, there is no DSL. It is just pure old Ruby objects. So there is no limitation. You can create your substitutes in any way you want. as long as they are compliant with those 3 rules about method names, arguments, and type of return response, type of response, as long as this is correct, you can do anything. What are drawbacks? Substitute is it's extremely hard to create substitute for active record, so it is the same how it is for mocks. Active record is a magic beast. We all love magic, but we scary about beast. So no one wants to mock active record. The same is substitute. I tried, spent 2 hours, and I failed. It's hard. Also, substitute of third-party gems. It is possible. I did that. It worked great. But this is this case, or this scenario, is when you evaluate one of the benefits. Now the life cycle of substitute and gem is independent, because there is another person who creates the gem and updates it, and you are responsible for the substitute you created. It's your decision, would you like to do that? And if you make this decision, then it is your responsibility to maintain your substitute. I created such substitute for one gem we used in project over a year ago, and there was no issues so far. But also all updates that was in gem, there was no major updates. So each time when we update the gem, we just check, is it major or not? When it will be a major update, I will be responsible to check my substitute. Is it still compatible? Okay, almost there. Substitute and request tests. In general, it's extremely hard to use substitute with request tests, because we are not creating instance of controls. It is middleware who creates the instance of controller. So, but it is not bad. In general, request tests are integrational tests, and integrational tests should test all elements in your project. Do they work together correctly? So I know what Aspect saying about control tests. We shouldn't use them because they just worse than request tests. They don't test routes and so on. But control test is a unit test, and it is exactly the place where which work well with substitutes. So strategic which I use is I create a controller test and test their all possible combination, all possible scenarios, and also I have one request test for successful scenario, at least one. In this way, I have guarantee that I have a well-tested system, because I have unit tests for all cases and one which tests that all my elements are connected correctly, starting from routes and ending on the database without any mocks. And more benefits: substitutes could substitute system libs like file. And this is quite interesting case, because in one of our project we have it's required to save some information in file. And when you have CI tests, and let's say they are in doc, the only option to test without mocking is to have shared memory for your docs. And it is not, it's doable, but it's additional financial part, and also additional work you need to do in DevOps part. But if you create a substitute for your file, which is not so hard, and I can show you later with a lot of beer, then you can avoid those additional costs and additional DevOps operations, because everything is tested in memory. Oh, and this is one thing that I missed. When you create a substitute, most of cases your tests are extremely fast, because you test everything in memory. But it is topic for another presentation. It will be too much to explain it in one day. And fun fact, everyone who worked with Action Mailer in Rails, they know that in test environment it behaves in different way. You not need to mock anything in Action Mailer, but you still can read what mail was sent and where. And this is because the Action Mailer use substitute. Substitute is, and you can find this inside the gem. There exists completely different class which has a whole toolkit to test mailing. And yeah, so it is the fun fact. Please next. Things worth mentioning. First of all, if you will read any materials or watch any video I mentioned in this presentation, and they use a lot some DSL from gems from Eventide project. For instance, dependency macro and configure macro. I avoid this because I didn't want to put too much information, too much DSL into examples. But they are simple, and now after you listen to my presentation, I'm pretty sure it will be obvious how they work if you see examples in video or in documentation. And also, they often talk about mimic gem, which is some type of substitute, but it is very primitive. Maybe not primitive, it's base substitute. In general, it's a null object. It has all the same methods as the object it substitutes, but it always returns nil as a response. So, and there is a telemetry, so you can at least test what arguments was passed to the substitute. So, and one of the things is, in my opinion, there is very little information about substitutes in all those documentation and videos. They always only talk about mimic. So if you're interested about mimic, you will hear this in the video and documents. Here you have another QR code for the video. It is from Utah Microservices Meetup. They also talked about useful object doctrine, and they, in more details, go through all those steps of evolution code, which I today showed. In this video, you will hear more about patterns they used, more about reasons why it is important, and there you will see also dependencies, and so those macros, and you will see the mimic. So, highly recommend. It's very good video, but it takes over an hour and a half. My presentation if you want. Thank you. Questions?
Hi, thank you for your presentation. I have a question that, as I understood correctly, you most of all use substitutes in your tests. And substitute is like total copy, as you said, like the same methods, the same type of the return from that method. But we don't test those original classes. So, and it looks like it's more like convention that it should be the same.
As when you use unit test, you test the code which is implemented inside your file, but you not test your dependency, because your dependency is supposed to be tested separately. So in general, when you use substitutes, you substitute your dependencies, but you still test the implementation of the service itself. And if, for instance, you have class A, which has multiple dependencies, and for instance, one of them is class B, and class B also have some dependency, then you create a unit test for class B, and you use substitutes for its dependency, let's say class C, but the code, the implementation of class B, is tested in this unit test. And the only thing that substitutes provides, maybe not the only one, it's first of all create an encapsulation for your test, and second, you have complete control about what return and how behaves your dependency. So this is the idea behind Substitute, is to have control over your dependency behavior. Okay, hope it's explained.
So it's not the case when you, as a developer, can make vary by substitute, that it will have another logic. So it's kind of a tool for you to manage your dependencies in tests.
Yeah, and one of the benefit or purpose or goals, I don't know which word I should use, that your substitute and implementation of dependency lives together. So this is very important part, because this concept push you as a developer to update your test tool each time, so you not have stale tests. Okay.
Thank you. Where do you keep the code for Substitute? Do you have a separate file for it, or do you directly leave a nested class in class?
Yeah, it's up to you. In our project, most of the case, because we have quite short files, so we keep our substitutes at the bottom. So it's namespace, it's sub namespace, but in the same file. But there are few cases when we have a bigger class, so we put it to another place. But it is true for our Ruby code, because we have a lot of pure Ruby components and elements, gems. In Rails, you probably want to use to put it separately to have this sidework flow, auto-loading and so on, because when you create a gem, you have a separate file which loads your all not depends, but all your files. You have to list them. With Zarberg, you don't do this. So, but it is not the only thing you should keep eye on is that your substitutes should be in sub namespace of your class, but which file you use, it's up to you, and it depends on how you lay out your code in the project. So it's up to team. Anyone?
So let's say you have a huge project and you would like to start using that functional object. And so how do you distinguish? How do you would add some prefix to the file name, or create a separate folder for that? How to distinguish that? How would you like to mark that this file is being made using those principles?
There are multiple approaches. First, for instance, in one of my pet projects, I use this technique too. And in general, I have folder models. And in folder models, of course, I have different models like user and so on and so forth. And this was a moment when I tried to create a substitute for active record. So, and then I just created a file. So I had model user. So I created a folder user. Inside this folder, I have file substitute. So there was my code. So Zywork worked correctly with this to auto-load this. But you could do something different. If you don't require Zywork, if it's not important to you, then you could have it's even completely out of app folder. You can put it to lib. You could have, for instance, there is approach that multiple person think that all your features should be implemented like a gem. So you should put them into the lib and just load those lib folders to be able to access from your application. And in this case, all your substitutes could be placed in any layout you want in this lib, because it's then your responsibility to load those files. So it depends. If you want Zywork, you have no choice. If you want to something else, it's your responsibility and your choice. It's the one of the beautiful, the part which is beautiful with substitutes, it's Poro, so you can do anything. It's pure Ruby. Ruby.
Okay, thank you.
Okay, then I think if no one has more questions, or maybe you want to talk with me later with beers, thank you for your time, and see you later.